There are a lot of times as a data scientist where you'll need to combine or merge data from two or more places in order to help you with your analysis. In this module, I'm going to go over the most common ways to do this with SQL, using subqueries and joins. In this module, we'll discuss subqueries, including their advantages and disadvantages, and some general best practices when using them. We're going to revisit the concepts of a key field from earlier in the course, and we'll talk about these and how they help us link data together with joins. I'm going to introduce you to several types of joins, including Cartesian joins, an inner join, left and right joins, full outer joins, and the self join. And assuming you're not all joined out by that point, you'll also learn how to use aliases and pre-qualifiers to make your SQL code that much more cleaner and efficient. As with all our modules, we have a lot to cover here, so let's begin. Things are starting to really heat up for us now with SQL because we're finally getting to a point where we're going to be able to use multiple tables together. Up until this point, we've just been working with a single table, and we've learned how to do some cool things. We can get lots of data returned. We can perform some calculations on it, but we're still really limited in terms of what we can do because we're only using one table. And where we get a lot of value in relational databases is when we combine different facts, dimensions, and sources together to obtain new meaning. One of the easiest ways to do that is with something called subqueries, which is what we're going to focus on in this lesson. After this video, you should be able to define subqueries, discuss advantages and disadvantages to using subqueries, explain how using subqueries can help us merge data from two or more tables together, and write efficient subqueries to make your data analysis smoother. So to begin, let's define subqueries. In essence, subqueries are queries embedded into other queries. It's literally just a query inside another query. So far, we've only worked with a single select statement and a single table. But when you're working with a relational database, since data is stored in multiple tables, you may need to merge these together or get information from multiple sources. Data scientists often use subqueries to select specific records or columns and then use that criteria as a filtering criteria for the next thing they want to select. Not only are subqueries helpful when it comes to getting information from multiple tables, but they're often used for adding additional criteria like filtering criteria that's not in your current table from another table into your query. Let's look at another example of this. Let's say we want to know the region each customer is from who has had an order with freight over 100. Maybe we're wanting to look at our shipping costs and say, who's really had heavy freight and where are these coming from? If we did this with the normal method we have right now, since this information is in two different tables, the customer table and the orders table, we would have to first retrieve all of the customer IDs for orders with freight over 100. But then we wouldn't have what region the customer is from because that's in a different table, the orders tables in this case. Then I would have to go and retrieve the customer information to get the regions from that separate table. And then I would need to combine that, so now I can select the IDs for the ones that had freight over 100. Clearly, this is quite a few steps, and we always want to limit these and make things as simple as possible in SQL. In this example again, you can see we pulled our customer IDs where freight is over 100. To do another query, to get my company name from my customer's region, and then now combine the list of those customer IDs into my other query, which had my customer information. This is also taxing right now because I just had a few customer IDs. So I could just say where a customer ID is this, because I've already pre-qualified this as being over 100 in freight. If that was a large list, this would be very taxing when either trying to find a way to manually copy and paste in, or also computationally for it to go through each one and match it. So to avoid this mess in SQL, we write what are called subqueries. We can take the three queries we had to write to do the job and instead combine all three queries into one larger query in order to make things more efficient. What I usually do when writing a subquery is start with the innermost query. How we're using this query is to filter for customers that we're getting back. My filtering criteria in this example is to find records where the freight is over 100. I'm first going to take that first query I wrote, which is to select the customer IDs from orders where freight is over 100. And that's going to be my main base. I'm going to filter down to that, and then I'm going to go and expand and add on to it. This is your innermost query. From there, I'm going to write the query to select my customer IDs, my company name, my region, to get my region information. I'm going to get that from inside the customer table. Where now I can connect the subquery and my customer information query together is using the where clause. When I say is where the customer ID is in the select statement, remember we're using this kind as a filtering criteria. It's saying only to return the region, company name, and customer ID for those customer IDs that are in this other select statement. A good way to think about this is that the query statement is always going to go perform the innermost select portion first. It's going to say, okay, I've got the customer IDs where the freight's over 100, and then it's going to sit there with them. Then it's going to go through to bring in the customer ID, company name, and region, but it's going to match to the customer IDs up against the list it pulled earlier to see if the customer IDs are actually in there. Then it's only going to return those customer IDs that were actually in that list of the select statement. You can see this helps reduce the number of queries we have to write, and it also helps keep everything concise in one query. Two things to remember about this in the innermost query is it's always what is performed first. If I'm looking at somebody's query and trying to troubleshoot it, I always start with the innermost query to see what's going on, and then slowly from there build and work backwards. In this example, remember the database is really performing two operations. One, it's getting our customer IDs with the criteria freight over 100. Then it's going and pulling the other customer information and matching it up against the customer IDs we've already pre-selected. Okay, this is a good place to stop for now. You know all of the basics with subqueries, what they are, when they're advantageous, how they help us when combining data from multiple tables, and how to write them effectively. Keep all of this in mind because we're going to be using subqueries a whole lot more from here on out. Welcome back. So in our last lesson, we started a discussion about subqueries, and we're going to continue that discussion here by discussing a few notes on best practices with subqueries. After this particular video, you should be able to discuss how to write a subquery within a subquery within a subquery. You get the idea. Discuss some performance limitations with the overuse of subqueries. Explain how to use subqueries as calculation. Describe some great general best practices when using subqueries. Okay, to begin with, one of the things you'll note is that there's no limit to the number of subqueries you can have in a statement. You can have a query inside a query, inside a query, inside a query, and just keep querying until your heart's content. However, you will start to notice that performance in obtaining your results does slow down as you get deeply nested and write long query statements with a bunch of subqueries. One thing to note is that subquery selects can only retrieve a single column. You can't say, hey, go select all these columns from this table and then bring them in my overall query. It's only going to select a single column at a time. Again, this is why they're used in filtering a lot. As you can see, this is just an example here of subqueries in a subquery. We have 3 different queries here. This one is nicely indented, so it's a little bit easier to read, which is a good practice because if everything was just lined up, you could get lost very easily, and it's hard to see where you're at and where things are coming from and what's happening. One of the things that's really important when you're working with subqueries is to make sure you're properly indenting things. This is going to really help make it easy for you and others to read. Here's an example you can see when I removed it from the indentation, and it's really hard to see what we're doing here, where things are starting and where things are ending. So if you're writing subqueries, make sure that each select statement is indenting and starting on its own. A helpful website for this is SQL. If you're getting something from an application that generates SQL and they're just really difficult to read because they aren't automatically indented, I always just throw it into this website and it pre-formats it, indenting things properly so I can easily interpret it. It makes it a lot easier to read. Then if you're writing them, just be really clear and consistent in your indenting with your queries. This will make it a lot easier for not only you, but for someone else to read when you or they are troubleshooting a particularly complex query. Okay, just one more example of subqueries. Subqueries can also be used as calculations. In this example, we want to get the company name and the region, and we want a total number of orders for these customers. Before writing the subquery, what we could do is we could count the number of orders for a particular customer ID, but then we still wouldn't have the customer name and region information. Instead of doing something where we're trying to combine these two together, we're just going to write a subquery. And instead of using the subquery with the where clause, this is actually one of the columns we're selecting. As you can see, we're selecting company name. We're selecting the region, and then just as if we were going to select a different column name, we have our whole subquery in there. We have select count as orders from orders. And then what we're saying is we want to count these based on the customer IDs. It's aggregating the orders based on the customer IDs. This is saying where the order customer ID equals the customer's customer ID. This is coming from the orders table, and we're matching it up to our where query through the from of the customers table and the customer ID. Then we just close our subquery in brackets and finish our select statement. We're getting this from customers, and we just want order by the company name. Now you can see we have our customer's company name, we have the region they're from, and then we have the total orders for that. In this example, you can see it just treats it like another additional column, but really helpful when you're wanting to do some calculations and do a calculated fill on another table. Okay, so to sum up, remember, subqueries are very powerful, but consider their use very carefully, because it may not always be the best thing to use for performance reasons. There's a lot of other ways we can get the result and not have to use subqueries. For example, later in this course, we're going to talk about joins, how we use them and what they're for. But it's important to know what subqueries are and how they fit into the grand scheme of things. This is just one of many techniques we can use to start to combine information together from multiple tables. We will continue on with some additional ways to combine data in the next few videos. Hello, and welcome back. In our previous couple of videos, we began to introduce some ways in which you can combine information from multiple tables, primarily by using subqueries. As we learned though, due to some limitations, subqueries aren't always the best way to combine information. In this video, we're going to begin to go over joins, another very popular method for combining data from multiple tables together. After this lesson, you'll be able to discuss the benefits of relational database systems, describe what a join is and how to use the join function to combine information from multiple tables, and describe how a key field is used to link data together. So before we start to talk about joins and why we use them, let's do a quick recap on relational databases and why we use them. Remember how we talked earlier in the course about how understanding the database and how they relate to each other is really important in terms of writing your queries? Well, I think you're really going to start to see why when we start joining tables together. Until very recently, we've just been working off a single table, and we've been able to perform a lot of functions and get data. But more often than not, the data we're after is stored in multiple tables. And so that poses a problem when we want to bring all this data together to blend it into analysis that we need. And then there's some reasons that we store the data in multiple tables. One of these is that it just breaks down the data for more efficient storage. So if we have an individual record of someone, and instead of breaking it up between maybe consumer demographics and then the products that they ordered and had all the information in one table, we would have duplicate information within a record. So the orders that they make may change, but something like their location may not change as frequently. So when we split out the information into separate tables, it helps us to more efficiently store the data that we have, so we're not duplicating records. This also makes it a lot easier to manipulate the data, so when we want to update a record or change something, when that data isn't touching all different levels, it's a lot easier to manipulate. This allows us the opportunity to scale the information. So there's a lot of reasons why breaking down the data into different tables is beneficial. But how we break the data down into tables is often modeled after a business problem or business process. So remember, we talked about this in terms of data modeling and our relational databases. A lot of times we'll take the tables and then reduce them in a way that has its own kind of theme or process. And then to get the data to come together, we use keys. This helps us so we don't have to duplicate the data in multiple tables. We're able to join those tables together based on an individually unique key. So this key serves as a link between the tables, and this key is a critical piece to being able to join records and tables together. So the first thing we want to go over with joins is that these joins are what associate the correct records from each table on the fly. To help explain this, again, we'll go back to our example of you have a table that lists the different customer demographics, but you want to know all of the orders that the customer has made. So a join will allow you to associate the correct customer information with the correct order quickly and on the fly with your query. This also allows you to retrieve the data from multiple tables in just one query. So instead of what you've seen in the past, and the reasons why you do subqueries instead of going and grabbing a portion from one table and then a portion from another table and then trying to merge that information together, instead, this allows you to write it all in one query and easily bring data from multiple sources together. It's important to note that a join is not a physical entity. In other words, it doesn't create anything permanent. It only exists for the duration of the query execution to help you get that information you're trying to get. Now there are several types of joins, and we're going to go over some of the important ones beginning in the next video. But let's stop here and reflect on what we've learned about joins so far. We began with a review of relational database systems and discussed how multiple tables are useful and efficient for storing data. We introduced the concept of a join and how it's used to combine information from multiple tables into one query. And we wrapped up by talking about how keys help us do this. Don't worry, there's more to come. Welcome back. So now that we understand the basics of join as a concept, it's time to explore the different kinds of joins and how to use them. The first join we're going to go over is called the Cartesian join, which is also often referred to as the cross join. After this video, you'll know all about Cartesian joins because you'll be able to define Cartesian joins, describe some specific cases on when Cartesian joins are useful, and write the appropriate syntax to establish a cross join using SQL. So to begin, with the Cartesian join, this allows you to take each record from the first table and match it with all of the records from the second table. So a way to think of this is the first table contains X rows and the second table contains Y rows. You'll have the end result of X times Y. So as you might guess, this is computationally taxing because if you have a table with just 10 records in it and the second table with 10 records, just performing a cross join is already going to increase it to 100. And rarely are you ever working with a table with just 10 records. So these aren't frequently used, but they're helpful in specific cases. So how do we write this out, and what is the syntax for this? You're going to write your select statement, the first part, just like any other select statement. So we'll have our select, the columns that we want, and this will be going over the product name, the unit price that's from the products table, and then the company name from the suppliers table. So you'll notice I just listed out the columns that I wanted, even though they are from two separate tables. And then I'm going to list from suppliers where it's coming from. But it's also coming from products, so I'll list out from products as well. But in between that, I want to state the type of join I want to do. So for this, I have just stated from suppliers and then cross join with products. So this, because we are just saying, hey, times every record in the first table by the number in the second table, we don't need any key or qualification, right? So is no matching being done? So this is a very simple join that you can do. However, just be careful because it's not matching on anything, right? It's just simply multiplying what you had in the first table and multiplying those records with what's in the second table. So in this example, in our suppliers, in our products, we had 29 records in one table and 77 in the other table, and then our end result is 2,233 records. What we also have is the supplier name is with the product name and price. You can see that from the from clause listed the two different tables, and then we just instructed it on the type of join we wanted it to have. So again, a really simple join with these cross joins. However, just be careful in understanding why you're using them and when you're using them. One of the reasons I mentioned before, the cross join and Cartesian joins are very computationally taxing. You can see how quickly this can increase the size of your data, and it also has the potential to return incorrect results, right? We're not matching it on anything. It's just taking one table and multiplying it by the other. So really be conscious and aware of what you're doing when you're using the Cartesian or cross joins. All right, are you ready for some more joins? Great, because in this lesson, we're going to go over probably one of the most frequently used joins in SQL, called the inner join. After this lesson, you'll know how to define and describe an inner join, explain when an inner join is used, as well as how to pre-qualify column names to make your SQL code that much more cleaner and efficient. Are you ready to get going? Great, so let's begin. So an inner join is used to select records that have matching values in both tables. So this is where keys become really important in tables. As you can see by the diagram here, we have table 1 and table 2, and what it's going to return is only the records that are matching in both. So it's going to look for that key in that link, and even if there's more records in table 1, it's not going to bring those back. It's just going to bring back the matches. How we start to use this, though, is a little bit different in terms of the syntax. So again, we're still listing out the columns that we want from both tables. So we have our select, our company name, our product name, or unit price. But now instead of just saying, go and grab the data from suppliers and products, we also have to say how we want the tables to be linked. So we say grab it from suppliers, the type of join we're going to do, inner join, with products, and then what we're what you're listing is really that key. So we're saying is this is an inner join, and we want you to link it on the connection between the key. So the connection between the key, the two tables, is the supplier ID in the suppliers table and the supplier ID in the products table. So you'll notice, as I say here, that supplier ID equals supplier ID, but before that, I've pre-qualified which supplier ID. So I have the supplier IDs from the suppliers table that equals the supplier IDs from the products table. So one thing to note here with this pre-qualifying is that if this is pre-qualified as suppliers and I have another name in here that is also in the same table, I want to pre-qualify my name in my column. So if company name is something that was listed both in products and in suppliers, it wouldn't know which table to pull it from. So I would pre-qualify it by listing out suppliers before the company name like this, so that I would know for sure where to pull it from. Okay, so this is the inner join. We really just keep a lot of the same syntax in listing the two tables. What we've done differently though is we've added that link of what we're joining on and pre-qualified that. Now you can see the result that we get from this. This is now connecting only those products that had a matching supplier with them. We can, though, do inner joins on multiple tables. So in the last example, we just took two tables and said, which records are matching? However, we can perform this on multiple tables. However, one thing I would really be cautious against, though, is to be careful to not overly join. So joins are great, and they make it super easy to blend your data together. All you need is that key, but they are taxing in the computations that they're performing. So if you don't need a join, don't join. But the good news is there are no limits to what you can join. So to do this, you're just going to list out all the tables and define the condition. Here though, because I have multiple tables, it's really important that I'm pre-qualifying my names. So if you look in my from statement, I have orders and then I just list O. So I'm pre-qualifying the orders table as being O. I do this just because it's a little bit quicker to write out. You could just pre-qualify orders as orders. Some other people list out their tables where they say orders would be A, customers would be B, employees would be C. I get a little confused and don't remember sometimes the order in which I put them in. So the way I like to pre-qualify is the less I have to type, the better. But I also want it to usually be in a logical fashion, just because it's a little bit easier to follow if I don't remember which one it's coming from. So I have orders as O, customers as C, and employees as E. It's just an easy way then for me to remember. You can now see in my select statement, I pre-qualified all the column names, and this is just something good to get into. You never know if you don't know your data that well. You don't know if the same column name resides in another table. So being really specific about which table you want it to come from is always a good idea. And it's just a nice best practice to get into. So here I have selected O, order ID, C, company name, and E for employee last name. So I'm wanting to get here the last name of the employees and the company name with the orders that were placed for this. So for this, I need to join 3 different tables to do that. I'm going to say from, and I have my orders with an inner join on customers, and that's going to be joined by the customer ID. Again, you can see that I just listed out my pre-qualified name with O.customerID and C.customerID. So now, at this point, I have enough to get my order ID and my company name. So right now, I know at least the orders that were placed and the customers that placed them. Now I want to know the employees associated with those orders. So just after that statement, I list to do another inner join. This will be for the employees E table. And I'm going to join that to the orders through the employee ID. So I have O.employee ID. So that's coming the link from orders to employee, and that is equal to E.employee ID. So that's the employee ID in the employees table. So pretty simple in terms of adding additional tables on. The thing you just want to watch out for is making sure you're pre-qualifying your names and making sure that you aren't doing unnecessary joins. But the thing to be really careful about is that it's easy to make a join and get data return, but really make sure you're thinking about what is the type of join you're doing. How are you connecting these records? And we'll talk a little bit later about some things you can do to double check to make sure the number of records is the number that you were after and the number you want. Because like we've seen in a lot of cases with using SQL, you're often able to get data back with any structured query. But we really want to make sure it's the right data that we want in the first place. Okay, so in the next few videos, to wrap up the module, we'll just be going over some more features with joins, and we'll be up and running with combining multiple tables here soon. Stay tuned. Welcome. In our last video, we talked about qualifying your table names, and so we've touched on this briefly, but I just want to go into it a little bit more detail in regards to using table aliases. We've used aliases when we are aggregating a field, so if we're taking the average selling price, we'll oftentimes create an alias for that so we know what to call the name. We can do a similar thing when we're using tables and joining tables together. And why we do this is because it makes it a lot easier to read and write. If we are joining two tables together and we need to state where each individual column is from before we state that column, it can be a lot to write out an alias as some of the table names may be quite long. So in this video, we're going to show you how to create aliases for use in our queries, discuss some common naming conventions when using aliases, and discuss and establish self-joins within a SQL database. So an alias is helpful because it can help you by just shortening names and simplifying how we're pre-qualifying them. Then something nice about the alias is it's not rewriting the name of the table or rewriting anything. It's just only stored for that duration of the query. So an example of this is in the query example. We have some information we're pulling from vendors and products. And so before every item that we're pulling, we're listing out its vendor name, where it's coming from, and the product name, product price. We're listing the name of the table before we're pulling that column name. Then we also have the same thing on our join. We're seeing where are the vendors for vendor ID goes and the products for the vendor ID. We start to use the aliases. What happens is it simplifies what we're writing quite a bit. So instead of having vendor name, all we have is V and then the name, or instead of having product and then the name, all we have is P and then the name. Same thing with price. Instead of having product price, we just have P price. To qualify this or create the alias, we do this when we're saying when we're getting the table. When we're getting it from vendors, we're going to say vendors is going to be V, and then products is P. Again, you can make these aliases as anything you want. Like I said earlier in the course, some people like to do A, B, C, D, but I like to keep it in a logical fashion. Some people also like to abbreviate the names of a little bit. So instead of maybe using V, it'd be VEN for vendor or PROD for products. It's really up to you. This is what I found helpful, so you're welcome to use that, but do what suits you. Then you can see in our where clause, it also simplifies that as well. So instead of fully writing out vendor or product ID, we just use the V and the P again. Again, just a really helpful little tip you can do. you can always write it as V or just do vendor as V. And that will also help when pre-qualifying in most database management systems. Okay, so back to joins. We can actually join a table to itself. And perhaps not surprisingly, these are called self-joins. In this instance, what we're going to do is we're going to match customers that are from the same city. We have all of our customers listed out in the table and where they're from. But we want to match these, so we're going to take the table and almost treat them as two separate tables and join the original table to itself. To do this, what it's going to have to take is you'll have your select statement, you'll have your column names, and then what you're going to do is when you list where it's coming from, you're going to qualify table name 1 as table name 1 and then table name 2 as table name 2. So if we look at this in our example, we have select our company name, and that's going to be company 1. We're qualifying that. Then we're going to select company name again as company name 2. And when we're going to select the city that we want this from. To get these tables, we are listing out the same table customers 2 times, but you can see we're qualifying it in 2 different ways. So first, it's customers is A, and then the second time it's customers as B. To do this then, and to join on itself, we're going to say where A.customerID equals B.customerID. And city A.city equals B.city. And then just to make it easier to read, we will order by A.city. So this is a great example why table aliases are so important, especially when you're joining a table to itself. You have to have a table alias. There's no other way this could happen. But also they really help you to stay clear on what's coming from what. So this is a really helpful method when you want to match certain elements that are in the same table, and it's a great tool to have in your toolbox for SQL. Okay, that does it for this lesson. So buckle up because we have some more joins coming at you in our next video. All right, so if you're keeping count at home, we've gone over 2 important joins so far. And in this video, we're going to go over a few other core joins, including the left join, the right join, a full outer join. However, before we get started, I just want you to note that only the left join is available in SQLite, which as you know is what we're using in this course. The right and full outer joins are definitely found in other database management systems, which is why we'll go over them in this video as well. After watching this video, you should be able to explain how a left join, right join, and full outer join work, identify situations where it makes sense to use one join over another, and use these joins to combine data from multiple tables. Okay, we're going to start with the left join. First, because it's pretty universal to most database management systems, including SQLite, so the easiest way to understand what a left join is going to do is to look at the picture and the diagram here. The left join is going to return all the records from the table on the left side, so the table you first state and the matching records with the second table. So if you look at the customers who had an order, and let's say you have a customer who has given you their information, but they haven't placed an order. And so if you did an inner join on a table 1, which was customers, and table 2, which was orders, and you did an inner join, you'd be missing the customers who haven't placed an order. So what this is going to do is it's going to allow you to say, hey, I still want everything from the customer table. I don't care if they didn't have an order, but if they did, and then bring it also all together and bring it in one order table. So that's the left join. The right join is very similar, except in this instance, if we still stick with customers tables is on the left and orders is on the right, what this would do is pull in all the orders whether or not a customer is associated with that order or not. And then, for the ones that do have a customer associated with it, it would pull in those records as well. So a little bit different. Really be careful if you're using left and right joins and which table you're listing as coming first, and make sure that relates to the left or right in the type of the join you use. For the full outer join, this will return all the records where there is a match in either table 1 or there's a match in table 2. So this is just saying, hey, just return and give me everything, whether there's matching 1 or matching 2. So we'll go into a little bit more detail about these joins. We'll use these frequently, so we'll want to make sure we really understand them. The first one is, let's say, again, we're talking about customers who have an order, right? So this one, we want to get a list of all those customers, whether or not they had an order. And if they did have an order, we want that information as well. So we just want our company name from the customers, the order ID, and then we'll say where it's from customers, which we're pre-qualifying as C. We're going to do a left join to the orders table, which is O, and then again our link is that which is on C.customerID equals O.customerID. So this is really what's pulling it together in the middle section. But what you'll notice is what we listed out as first. So we're going to be getting back all the customers because we're doing a left join, and that's what we have listed first. So go ahead and play with this. This would be really fun when you're experimenting. Look and see what you get back when you list the customers first versus the orders first. And that's a good way to test your join and see what's happening. Depending on your data, every customer may have an order, so you may get the same results. But maybe every customer doesn't have an order. So again, it all comes to knowing and understanding the data you're working with. So for the right join, what we're looking for in this is we want to return a statement with employees and orders that the employees may be associated with. So for this, again, I'm pre-qualifying my names, except I'm not pre-qualifying it in this instance as O. I'm listing them fully out. So you can see how it gets a little bit longer in what I'm writing. I'm just going back and forth and showing you the different ways to do this, but still getting the same results. So I have my columns right after my order ID, last name, and first name. I'm getting this from the orders table, and then I'm going to right join the employees on orders. And this is going to be on the same employee ID from the orders table equals the employee ID from the employees table. So you might ask yourself is, well, couldn't I have done the same thing and done a left join, but just switched up the order of the tables? And so instead of saying I want a right join where I'm getting all the employees back, whether they could have had a match or not, I could have just listed the employees first and done a left join. And this is true, so good thinking. I'm glad you are paying attention. This is 100% true. You can just switch the order of that. And that is why it's not a big deal that SQLite does not support the right joins, because if you need to do this type of join, you can just switch the order of the tables and do a left join. But still, it's something to be aware of in case you come across it in other queries that you might be reading or using from a different relational database management system. So you'll be able to use it. Okay, so now the full outer join. Again, this is not supported by SQLite, which we'll be using, but I just want to touch on it briefly in case this is something that you come across in a different database management system. In this example, the select statement is going to select all the customers and all orders. For this, again, we pre-qualify our column names. We say where we're getting it from. We're getting it from the customers table. We say the type of join we're doing, full outer join, to the orders, and then we list what we're joining it on. Again, it all follows a similar syntax. Just be aware of the type of join that you're using. So that's our more advanced joins, left, right, full outer joins. They all have their particular use cases. Just be careful when you're using them in the way you intend to in order to get the results that you expect. We have one more important, though seldom used, join to talk about, and we're going to cover that in the next video. See you there. Hi there. So by now you might be all joined out because we've covered a lot of different joins in this module. But there is one more that I want to go over with you, and that's called the union. The union is one of those things that I wouldn't say I use a lot in my day-to-day work, but when I do need it, I'm like, yes, this is exactly the thing I need to use to get the job done. So I think it's useful to go over it. It's kind of like a secret weapon. It probably won't be your go-to, but you're certainly not going to use it every day. But when you do need it, it's going to save you a lot of time. All right, so after this video, you'll be able to describe what a union does and how it does it, discuss the parameters and rules for when you can employ a union, write out the appropriate syntax for a proper union statement, and describe some common situations where it could be useful. Okay, so to begin, a union is used to combine the results of two or more queries or table sets into one table and one statement. So each select statement gets union with each other and kind of stacked on top of each other. The best way I can think of this is when I may ask someone to build me a building that's 20 stories tall, and I have two people to build it, so I may ask the first person to build the first 10 floors and the second person to build the top 10 floors. So that's great. Both of them can work independently from each other, but at the same point, I want to put these two back together. And so it's really important to know where the stairs are at, how wide or long the building is, to make sure that everything's the same size and can fit back together. It's kind of similar with the union. So you have two separate pieces, two separate tables or queries, and you're literally going to just stack them on top of each other. So to do this, you must have the same number of columns, right? Going back to our metaphor, the building needs to be the same size, and you must also have similar types of data. So you can't just throw an integer on top of a string. The data types need to be the same. And if there weren't enough, then I also want to make sure the columns are in the same order. So I want to make sure my whole building is the same size, and I want to make sure that the floor plans look similar. But if I put the stairs on the west side in one building and then the east side on the other building, that's not going to work out very well. So you also want to make sure your columns are all arranged in the same order. Okay, let's look at an example. What we're going to do is select customers from Germany, and we want what cities in Germany our customers are from. We also then want to know what cities we have suppliers in. And so what we're going to do is where we're going to write two separate queries. One to get what cities from the customers, and then the cities from the suppliers. And then we're going to add those together so we know where we have a presence, whether it's by customer or by supplier. So the syntax for this is you have your select statement with your column names from your table, and then you list where the union, and then you also have your second select statement. So this is different in fact that most of the joins we've been doing up to this point, we have our whole select statement. We say where and how we want it joined. This we say our select statement, we say our join, and then we say the other statement that's going to stack. So in our example here, what we have is our first statement. So we're selecting city and country from customers table where the country equals Germany. So for this, we don't have to have the where clause, but we just want to limit to Germany. Then in our second statement, we're going to first say union, and then we're going to write our second statement. So now we're selecting cities and countries, but from the suppliers table. Again, we want just the countries of Germany, and we're going to order these by the city name. So now we have a list. Maybe this is something we want to plot on a map for marketing to say, hey, look, we have business relations with all these cities in Germany. And so we're classifying our business relations as both customer relations and supplier relations. And so now we have a really nice list that we could go and plot on a map. Somewhere to say where all our customers are and list our business relationships out. So that, in a nutshell, is a union. You should now have a good idea of what it is, how the tables need to be constructed for it to work properly, how to use it in a select statement, and a situation or two where it might prove very useful to you. Again, this isn't an operator I use every day, but I use it enough that I think it's handy for you to know. Congratulations, you've finished another module. So joins are a pretty simple concept, but they're really powerful, right? So now we've just expanded what data we're able to pull by however many tables we have, especially if we have a unique key linking them together. So now our queries can start to get really complex because of the number of fields we're going after and how rapidly they've increased. Again, as we've always said with SQL, probably one of the hardest parts about it is that it's easy to get results. You just need to be sure you're getting the results that you want. Now that you're joining data, you don't want to see what is happening to every record or how it's matching. So you need to make sure you're going through and checking your results. If you're doing a Cartesian join, check the number of records in the first table and the second table and multiply them to make sure it's the intended outcome. If you're doing a left join and you know how many records are in the left table, make sure that's the number of records that you are getting back in your results. Everything's going to be brought over from the left table. Another thing to do is check for duplicates. So unless you said something where you're doing a union and you don't care if there's duplicates, check and see if somehow your join got messed up and there's duplicates. So let's go over a few quick things you can do to start to make sure that our joins are working well. 1, check the number of records you have each time you make a new join. Did you lose any records? Did you gain any records you weren't expecting? And then the other thing is to look for duplicates. So as you start to join more and more tables together, it's going to get more complex. So really start small. Start with just one table. Check it and add another table. Check it and move on from there. As I said before, the most important thing I can teach you in this class is to slowly do. So I know it's so easy to get in and you want to write the query and pull some data, but it will definitely benefit you in the long run and you're going to get a lot further ahead if you stop and think about what you're doing first. So even if you just need to draw the two tables and draw how they're joining together in a picture, that can help a lot. Just taking the time to slowly think through what you're trying to do will be really helpful. I encourage you to actually think about what's actually happening in the query. Determine how these records are going to be merged before you actually even sit down and write the query at all. Even though you might think that you should be writing, typing, and putting in code, I promise you, taking the time to really think about things through will save you a ton of time and frustration in the long run. So another thing to remember is always with the joins, you'll need to use a join condition. So unless you're doing a Cartesian join or unions, but the inner joins, the left joins, and the right joins, those will all need a join condition. Usually you'll be working with inner join. However, be sure to understand all of them because you never know when you'll need that secret weapon in your arsenal. Another thing to remember is the more tables you join, the worse your performance is going to get. So again, it's easy, just say, go get me all the data. I'm going to use it all for my analysis. Resist that urge and think strategically about your analysis. Don't grab unnecessary data if you don't need it. Why go through all the pain of moving it if you really don't need it? So think strategically about the data you need. As in life, only take what you need. Don't take more, don't take less. It's just a good habit to get into. And then lastly, The syntax for some of these joins may be a little bit different based on your database management system. Most of these joins, except for the right and full outer join, should work with SQLite, which we're using in this class. But if you're using something different at work, just keep that in mind. So there's a lot of different diagrams you can find on SQL joins. I think if you just Google SQL joins, there's a lot of ones that will come up. I really like these because it provides a visual to help me kind of remember, okay, what's coming from what table? What's matching? And where are they coming from? Are all the rows coming? What's happening? So this is just a nice little diagram. I think it's helpful for you as you're writing your queries. And feel free to print it out. Keep it by your desk as you're getting started. But it really just kind of goes through and shows the differences between all the joins and what's happening there. Okay, you should now be all set as far as joining goes. I hope you're excited. Like I said, the data you can now work with has expanded dramatically. Just remember and think about what you're doing. Really put together kind of what's happening. Either write it out on a piece of paper just to break some of the abstraction down before starting to write your queries, but get in there and practice and you'll be getting the data you want back for your analysis in no time.
Thank you for watching our video. We hope you found it helpful. If you enjoyed this video, please hit the like button below and subscribe to our channel for more videos like this. If you know someone who could benefit from this information, please share it with them. We would love to hear your thoughts on this learning course, so please leave a comment below. Thanks again for watching, and we'll see you in the next video.